Heat capacity success is remembering several definitions that we're going to talk about. But the one thing that I particularly want you to recall is that the molar heat capacity of metals, whose atomic weight is greater than 40, is about 25.5 joules per mole degree Celsius. I'm going to show you how we get there. Let's look at heat capacity and the definitions that accompany it. Heat capacity itself is the heat required to raise the temperature of something, anything, one body. I don't care how much it weighs, 1 degree Celsius. But the ticket is, don't change the state of matter. Don't melt it, don't boil it, don't sublime it. Keep it in the same condition that it was. And the units are generally joules per degree Celsius or kilojoules per degree Celsius. Molar heat capacity is precisely as it sounds. It's the heat required to raise the temperature of 1 mole of a substance 1 degree Celsius without changing the state. And the units as a rule are joules per mole degree Celsius or kilojoules per mole degree Celsius. The specific heat is the heat required to raise the temperature of 1 gram of a substance. Specific heat is specifically the heat for 1 gram. Got it? The heat required to raise the temperature of a gram of a substance 1 degree Celsius without changing its state. So logically then, the units are going to be joules or kilojoules per gram degree Celsius. Now, I want to show you something. Let's look at some specific heats. Look at water. Water has an incredibly high specific heat. 4.184 joules per gram degree Celsius. The heat required to raise the temperature of 1 gram of water 1 degree Celsius, that is really high. That's why water works so well, to keep the temperature of an area about the same, to keep it fairly constant. Areas that are on the water generally don't have as extreme variations in temperature as land areas that are away from large bodies of water. But look at copper. Copper is 0.387 joules per gram degree Celsius. That is an awful lot less. That is less than 1/10 of water. And gold is even less. And look at silver. It is also a very, very small specific heat. This tells us that it is very easy to heat these metals. Now, I want you to multiply the specific heat of each of the metals by its gram atomic weight. And when you do, of course, what you're doing is converting to the molar heat capacity. So I multiply that. We find the molar heat capacity of copper is 24.6 joules per mole degree Celsius. And for gold, it's 25.4 joules per mole degree Celsius. And for silver, it's 25.6 joules per mole degree Celsius. Isn't that interesting? It is true that for the metals whose atomic weights are greater than 40, that the molar heat capacity is right at 25.5 on the average joules per mole degree Celsius. So this means then, if you're ever given a problem and you need the specific heat of a metal and you don't have that specific heat, you can calculate. Here's an example. Let's calculate the specific heat of iron. Now remember, the specific heat times the atomic weight is equal to 25.5 joules per mole degree Celsius, approximately. So we take the specific heat, which we're looking for, times the gram atomic weight of iron to equal 25.5 joules per mole degree Celsius. And that came out that the specific heat was 0.457 joules per gram degree Celsius. Well, you might ask yourself, is that a very, very accurate value? Well, the National Bureau of Standards lists it as 0.452 joules per gram degree Celsius. So if you don't know the specific heat of iron or another metal and you need it, this is not a bad way to get in the ballpark. Brought to you courtesy of The Chemistry Professor, offering complete chemistry courses on DVD. Visit us on the web at www.chemistryprofessor.com.